We have this instrument cluster of a Peugeot 206 and we want to use it on our driving simulator. To do this, we need to find out how it works and how we can make it work on our driving simulator. On the back of the cluster, we have a yellow connector and a white connector. We've also got a bunch of wires coming out of the connectors, and we need to find out what the function of each wire and each pin on the connector is. We are mainly interested in using the speedometer and the tachometer. As a preparation, we've used the multimeter and beep function to find out which wire connects to which pin on the yellow connector. Each wire also has a color and is marked with a number. Together with the measurements from our multimeter, we've used this to create a list of all the different wires. We were able to find the wiring diagram of this particular car online, and using the diagram, we were already able to determine a lot of pin functions. However, from the diagram alone, it is not possible to determine which signal exactly will be used on which pin. But for most warning lights, we can already determine which pin will be used and whether they need to be connected to 12 volts or 0 volts to be activated. For the white outlet on the back of the instrument cluster, we do not have a connector, but with the help of a wiring diagram, we were able to identify which pins we need, and we used some jumper wires to connect them to our breadboard. After all the measurements were done and we've collected all the information, we were able to draw up a table containing most of the information that we will need for testing. This is a table for the white block, and it contains information about the wire number, the wire marking, the wire color, the function of the wire, how it can be activated, and any additional comments. So with all the preparations done, it is time to start testing. We are using a 12-volt power supply which connects to our breadboard, which then connects to the pins on the back of the instrument cluster. After double checking all the connections, we were finally able to turn on the power of the instrument cluster. We then proceed to test whether the functionality of each pin corresponds to the information we have already found. This example shows pin 3 of the yellow connector, which should activate the front fog light indicator when connected to 12 volts. So the indicator lights are pretty much straightforward on-off functions. The speedometer and the tachometer are a bit more difficult, because in the real car, Hall sensors are used to determine the rotational speed. And this shows an example of the RPM measurement. A Hall sensor is placed near a toothed wheel, which rotates together with the camshaft. This sensor then generates a square pulse which can be used for RPM calculation. This means that we will also have to generate our own square pulse. To do this, we'll be using an Arduino. We've created a simple sketch for the Arduino which allows us to generate a square pulse on the output of the Arduino with a duty cycle of 50% and a variable frequency. We've used some current limiting resistors to connect the output of the Arduino directly to the input of the instrument cluster. This means that the amplitude of the pulse will be 5 volts. And we can already see that the generated pulse activates the speedometer. The next step is to start varying the frequency to find out what the scaling in Hertz per kilometers per hour for the speedometer will be. To get a complete understanding of what exactly is happening, we are using a MyDAC. This device can be used as an oscilloscope, which we will use to get an exact reading of the input signal on the instrument cluster. We soon figured out that it was impossible to accurately steer the speedometer with 5 volts. This probably means that the controller inside the instrument cluster is expecting 12 volts pulse instead of a 5 volts pulse. So we created a circuit based on another Arduino which allows us to amplify the pulse signal. This circuit also has an analog input which we will use for a variation of the output frequency. The MyDAC, which we were already using, can be used to generate this analog input. So with everything connected and the speedometer frequency scaling determined, we can now accurately steer the speedometer to the speed we want. After repeating the same process for the tachometer, we have successfully determined how the instrument cluster functions and what we will need to simulate this. The next step is to design and build our own equipment which will be used for interfacing with the driving simulator. Be sure to check out our next videos for more progress on the instrument cluster and our Peugeot 206 driving simulator. Also, check out our website and other social media if you want to know more about DriveSimSolutions and all our products. All the links are in the description.